Very early on in my career, I learned about chaos and deterministic systems, and that was just very impressive to me. I studied the motion of the planets from the time of Newton up until the 60s. The consensus viewpoint was that the motion of the planets was regular, and it was just a matter of finding more powerful mathematical tools to prove that. There's a famous problem in the distribution of asteroids called the Kirkwood gap problem. If you look at the number of asteroids versus distance from the sun, then that distribution shows gaps at near resonances with Jupiter. So for instance, there's a gap at the 3-to-1 resonance where the asteroid goes around the sun 3 times every time Jupiter goes around once. What I did to study this problem was to invent a new integration method, and that allowed me to study the motion over much longer times than people had studied before. And I found chaotic behavior in the motion of asteroids near resonances. The property of the chaotic behavior of these asteroids is that they're all catastrophic. Their eccentricities increase to the point that they cross planetary orbits and even fall into the sun. So it turns out that the chaotic orbits are all removed and the regular orbits remain, and that's what forms the Kirkwood gaps. Jerry Sussman is a computer scientist, but he's also an amateur astronomer. And he also builds hardware. He heard about my result concerning the motion of asteroids. So what he did was to say, if I don't believe your integrator, but I can build you a computer to do the same calculation. And so he built this computer, the digital orrery. Then we used that, we collaborated together to use that computer to study the motion of Pluto. Pluto has a sort of suspicious orbit. It is resonant with Neptune. It goes around the sun twice for every 3 times Neptune goes around the sun. It took the calculation, even on a special purpose computer, took 6 months. And what we found was that the motion of Pluto is indeed chaotic. It shows sensitive dependence on initial conditions. And what this means in practice is that if you change the position of Pluto by 1 millimeter, then in 100 million years, it will be on the opposite side of the sun. Jacques Lascar was inspired by that result and studied the evolution of the whole solar system using an approximation of the equations of motion and showed that the whole solar system evolved chaotically.